Today's podcast is on blood typing, and there's a page in your lab pack and also posted on Moodle. It's page 43, and it gives a diagram of some of the things I have up here on the board. So the main point for blood typing is what determines your blood type. It's your red blood cells and the proteins that are found at birth on your red blood cells. And so we only have 4 types of blood. We have type A blood, we have type B blood, we have AB, and we have O. And so all the red blood cells, of course, are drawn in red. And now here are the pieces of protein that you are born with, right here. And so these are actually antigens. They're called antigens. And because they're on a blood cell, they're called agglutinogens. Agglutinogens. G-E-N is what you want to look for in the ending, because that means antigen, okay? And so this piece of protein in the type A blood is like a triangle, and it's attached to the cell membrane. You cannot see them except with an electron microscope. Type B blood, if you're born with this, you have little round circles, like beads, like little beads. They're going to be attached to the cell membrane of all your red blood cells, and those are round shaped, okay? And then in AB, you're highly decorated. You are highly decorated. You have both. You have A antigens and B antigens, and so you have both, and and they alternate on the cell membrane like that. And then type O blood, type O has nothing attached to its cell membranes. So they're like bald, right? And so no proteins at birth, never, right? And so the only 2 proteins that you are born with are either going to be triangular shape or they're going to be round shape. So this is antigen A and this is antigen B on red blood cells. So the name for it again, agglutinogen A is the triangular, and this one is going to be agglutinogen B, right? Because it's on a red blood cell in type B blood. And so I can abbreviate this A-gen B, right there, A-gen B, okay? And so that'll be the abbreviation for agglutinogen. We'll abbreviate A-gen, A-gen, right? So A-gen A, A-gen A is the triangular one. A-gen B is going to be the circular one. And then in type AB blood, we have both. And so we have A-gen A, A-gen B, right there. And so, of course, O has none. And so they have no antigens. None, right. All right, so that's nice. And so this is what your blood typing is based off of, the proteins that are found on the red blood cell membranes. All right, now, at birth, okay, then basically when you have these pieces of protein attached to the cell membrane, then what's going to happen is you develop antibodies to these pieces of protein so that your blood cells will not stick together. So I like to think of these antibodies that I've drawn in black here as sort of spacers. They space out the blood cells so that they can't attach to each other and form a clot, okay? And so if we didn't have the antibodies in your blood, then basically your blood cells would start sticking together and they would agglutinate, which means agglutination. And so this is why this is called agglutinogen. And so agglutination means coagulation, basically. And so we do not want to form clots. And so these are the spacers. They're made out of protein, okay? And so you have them at birth. And so basically, we'll put protein by them. They're pieces of protein. All antibodies are made out of protein. And so basically, they're going to develop at birth, and then they're going to be in response to this piece of protein specifically on your blood cells. So in type A blood, this piece of protein is sort of, we draw it sort of straight, and then it has rounded indentations. So it's sort of rounded right here. And so will this fit over this thing? No. And so this piece of protein will not fit over this piece of protein. No way. You see like this? Here's a little mini one right here. And so this will not form a clot. And so you have to have something that will fit over this piece of protein to make it clot and clump. And so this is just a little spacer floating in the plasma of the blood. So do we have a name for this piece of protein? Of course we do. And so it's called agglutinin. Agglutinin. And so basically you always want to look at this ending to the word, N-I-N, okay? And so this is called agglutinin anti-B, okay? And so can we abbreviate this faster? Sure we can. We can say this is A-nin, right here, anti-B, nin. Instead of writing this big long word out. And so both of these are pieces of protein, but basically this is the spacer, the antibody, and you develop these at birth. But when you're born, you already have these pieces of protein, the antigens. They already come with you. So they're already determined genetically by your parents. So that is type A blood. We have triangles, and then we have the spacers, the antibodies with the rounded ends. And now we're going to go to type B blood. So type B blood has antigens that are round, okay, like little round beads. And then we have the antibodies. The antibodies here. And so this is the antibody right here. And AB is the official abbreviation for antibody. Okay, and so basically, what do we call this antibody found in type B blood? It's called A-nin, here's that nin, anti-A. Because these are strange little structures. They're sort of rounded, but then they have like an indent where a triangle could fit in there. So if I gave this type of blood, these things would fit right over here. They'd snap right on to a triangle. You see like that? If that's a triangle, the triangles would fit right in there, and that would be disaster if I gave type B blood to type A right there. So basically, I'm going to erase this, and so that's what these things look like. So they're sort of rounded, and then they have the indented area that's like a triangle, okay? So those are called anti-A antibodies, anins, the anins. And so these are the antigens, again, agglutinogen B. So there you go. All right, now type AB blood right here, AB blood, they have both types of antigens. And so we've got antigen A and antigen B, the round one. And so they're highly decorated, no antibodies or amines, okay? And then type O blood over here. Type O blood has no antigens, but it's got both kinds of antibodies, okay? So they've got the anti-Bs right here, that will go over the beads, and they have anins, anti-As, with the triangles, the indented areas for them. And so this is type O blood. Now, here's the whole thing. They always say that you can give type O blood is called the universal what? Universal donor, right? And so type O blood, universal donor. So in the emergency situation, oh, we could take and give type O blood to AB, B, and A. But is that really correct? No, it has to be treated. So universal donor, there is a little caveat included in this. It has to be treated to remove the anins, the antibodies. You've got to remove them, right? Because if I gave type O blood in an emergency situation to AB, look at this. All of these would pop, these would come over here, and they would attach immediately like this. They didn't attach immediately to that. This would attach right here. This is going to attach right in here. This thing, well, I'm not very good at drawing this. And so anyway, it will attach and it will make the blood cells all make bridges together, and that's formed a clot, okay? That will form a clot, and so you'll have a nice problem going on. And so you do not want to make clots. And so type O blood would immediately kill AB because all of these would be sticking onto these, and then all the blood cells would stick together to form a clot. So, but if you treat this and get rid of these, why, it's no problem. It's no problem, okay? And so that's nice, all right? But, so when you say it's the universal donor, it has to be treated, and you have to remove these antibodies to give them to another type of blood. All right, and then, but if I didn't, if I was in an emergency situation like when 911 happened and they needed blood, and they definitely needed type O blood, and then they needed the specific kinds also. But basically, if I gave type O blood to type B, what's the chances of the person surviving? 50%, 50%. If I gave untreated O blood to type B blood, well, some of those antibodies are going to go and attach. They're going to attach right here. They're going to attach on these things. So they'd have a 50% chance of dying. But basically, if you could get the patient to the hospital in an emergency situation, then they can give them treated blood if they have it. But like in 911, they couldn't even treat the blood fast enough to save people's lives, okay, which was a real tragedy. But anyway, same thing. If you give type O blood that's untreated to type A, you're gonna kill, you got a 50% chance of dying, right? You're gonna kill some people with this untreated blood because they won't be able to survive and they'll form too many clots. And so basically that's where we get the term universal donor, because it's way easier to destroy these proteins in the plasma than it is to destroy these things, these proteins on the surface of the cells themselves, right? All right, so type AB blood is sometimes called, right here, universal recipient. Universal recipient. That means it can take blood from any other blood type. Well, that's not quite true either. It has to be treated, right? And so again, it's got to be treated blood so you don't form clots, okay? Treated blood, so equals no clots, right? And then you're going to save their life, correct? So basically, this doesn't have, it's got no antibodies, but if I give type B blood to AB, I've got, guess what? I've got these here, and so they're going to attach to these. They will attach to these. And so then that's no good. And so if I didn't treat type B blood and get rid of these, get rid of them, then this person will have a 50% chance of dying, right, when I give them my blood. Same thing for type A, and of course type O. Oh my God, that's disaster, because basically you've got A's and B's, the antibodies, and they're going to just attach real fast. So again, has to be treated to use those two terms, right? And when the Red Cross gets it, it does treat them. It does treat to remove the antibodies, absolutely. All right, so now there's only one other thing about blood typing. And so basically we always say you're type A, type B, AB, or type O. And your blood type also is race dependent. If you look up on a chart or a table, you will see that certain races, certain types of blood predominate, okay? So like for Caucasians, most Caucasians are type O. Native Americans are AB, that's the highest there. And so anyway, you can look that up. It's not on your sheet. It does not have a list of all of it, but I think in the lab book, there is a little table that lists all the different nationalities and the races and what type blood tends to dominate, right? All right, now, so also when we say your blood type, we usually say you're A positive or negative, and what does that mean? Well, basically, it means that you're gonna have an extra piece of protein on your red blood cell. And so if you're type A positive, okay, A positive, oh, you've got this nice extra piece of protein that you're born with. And this positive right here means you have an extra antigen, and it's called the Rh antigen, or a agglutinogen, okay? And so the Rh antigen, or agglutinogen, right here. So I'll underline this, right? And so it's an A-gen. And so that's all it means. Is that you just came with an extra piece of protein on your blood cell, red blood cell membranes. And so if you don't have it, you're negative. No Rh protein. None, okay? And so every blood type is either positive or negative for this, all right? And so I can do a neg here, and I can do an O positive right here. So what does Rh stand for? It was actually discovered by a veterinarian, the Rh factor in monkeys, and it's named after the rhesus monkey. That's a genus of monkey species, and so Rh stands for rhesus. And it was discovered in monkeys that were having a hard time. They were aborting their babies too soon, having miscarriages. And so a veterinarian looked at their blood type to see if there was anything in there that was causing them to make the baby be born dead and early. And so he came up with, oh, we've got this extra piece of protein that can be on the cell membranes, right? And so that can be a problem between the mother and the developing fetus. And so basically we're going to draw an example of how the Rh factor works when the mom is actually a negative and the baby develops as a positive.